So we've seen that representation is a complex issue. We've seen that there are good reasons to choose among various forms of representation. We've seen examples of well-chosen representations. We've seen successes using localist representations, distributed representations. We've seen ways of designing representations based on theory. And we've seen ways of discovering representations based on compression. All of this is great, but it comes with dangers. I said at the start that data don't occur free-floating in nature. A data point is always a selection made by a human observer who has specific motivations. There is an unfortunate tendency to treat data as if it were a freely occurring substance like air. So we're just going to look at how some of what we reviewed turns up in the scientific literature and then in public discourse in ways that lack the kind of caution that we've been so careful to instill. So we're going to review some really toxic science now, some of it contemporary. But we're going to start off with my own contribution, because if I'm going to present some bad science, I better do some myself. So I've come up with a plan for retirement. I'm going to patent this and make $1 million. It's my patented phrenological criminal detector. In the coming authoritarian state, it's going to be great use for spotting criminals before they commit their crimes. Precogs. I'm going to use my magnificent powers of representation and network training in order to do this. I'm not quite sure how to identify criminals, if truth be told. But if I can get me some data, maybe the data will teach me how to do that. So I'm going to get some images of faces, heads, and I know from the dark days of the 18th and 19th century that some people believed that you could tell a person's character by feeling the bumps on their skull. Not really a popular view these days. And what I'm going to do is I'm going to use the data that I collect and sort them into criminal and non-criminal types and train the network so that it can then generalize, so that when I present it with a face of someone else, it can tell me whether that person is a criminal or not a criminal. And data are easy to find. Here I've just mined a little bit of Facebook and there's a couple of faces. Supposing I happen to know that everyone on the left has a criminal conviction and everyone on the right is fortunate enough not to have a criminal conviction. I'm making this deliberately stupid. But there's nothing to stop me doing this. I can obtain a large data set of people who have criminal convictions and a large data set of people who have no criminal convictions, and I can train it. It's going to be hopeless, obviously. Otherwise, everyone would be doing this and making their millions. But I have an idea up my sleeve. So the reason everyone fails is because, well, it's a difficult task, apparently. I'm hoping that my database of faces is useful for this task, and what all those fools who haven't learned how to exploit this have done is they've tried to train neural networks on it and it fails. So you present your images, you train through a magic hidden layer, you have a single output unit that says yes criminal or no non-criminal, and it doesn't work. Not really surprising. We don't really know what facial features are going to be important in predicting whether someone is a criminal. I hope you're being cautious here. Here I'm relying on my training to do everything. And neural networks have a tendency to be used in this way as magic machines that are just black boxes. You give them input and they produce results. Pure magic. But we've learned a few techniques now that we can use. So we can develop compressed representations that capture similarity among faces, and we can do so hopefully in a way that will make our task easier. The way we would do this, and this is a kind of a step taken in many real network projects, is use an auto-associator first, in which we present images and get the network to reproduce the images at the output, but to pass the representations through a hidden layer which has less units than the input patterns. So our auto-associator is a way of developing these. Then we can take those hidden unit representations and train a black box feed-forward neural network to do the job, to do the categorization. So this should be no problem. We should be off to the races here. This kind of black box approach to networks is frequently encountered in the wild. And the fact that I introduced some sophistication here in developing representations using an auto-associator is no excuse for the nonsense I just perpetrated. We are here substituting computational magic for domain-specific understanding. Of course, there's no way to tell from someone's face whether they're a criminal or not. We have enough domain-specific understanding to know that this is complete rubbish. Understanding is, of course, hard to come by. Now, surely we would never find work as crazy as this in the literature. Well, here's an unfortunate stinker of an article from Trends in Cognitive Science in 2014, which takes facial data and tries to understand how people attribute certain characteristics to people based on their faces, social attributions from faces, bias, human choices. And it dives into particular feature-based representations of faces and interprets things very, very poorly. So they're not actually using neural networks, but they are using the trust that people have within the field of data science that their representations are sufficient for the task without asking themselves whether that's a good step or a bad step. So when this kind of data-driven approach is used in machine learning, we know to expect the worst. But this was 2014. Surely that's ancient history, and we're all over this. Here's a paper from Nature Communications 2020, which I'm going to call out as ignorant pseudoscience that encourages toxic debate. The paper caused something of a furore when it was published. A lot of people who are critical of the methods of data science were up in arms about this. It claims to track historical changes in trustworthiness using machine learning analysis of facial cues in paintings. Art historians were up in arms about this because that's no way to use paintings. But those of us who worry about the ethical consequences of research that is done in this manner also had cause to worry about this. This is nothing more than a scientific veneer on this kind of ludicrous illustration, telling a good husband from an unreliable husband based on their head shape. In the ensuing debate, the authors countered that they had been very careful not to misrepresent things, and that the paper, when you dove down into the text, was full of hedges and cautions and statements that limited the degree to which one might extrapolate from their work and generalize it. It took just a few days for this to appear in The Sun. Pretty Little Liars, we can reveal which celebrity faces you can and cannot trust, from Kim Kardashian and Holly Willoughby to Meghan Markle, and there's Joe Biden with a 58% trustworthiness rating. This is how such work then appears in the public domain. There is a responsibility on our science journalists to try to avoid this, but they are terrible at this. And I hope after taking this course, you have a slightly more cautious approach to such things, just because a model, that is something which performs a bunch of sums on numbers, is using data, does not make the interpretation of this by the researchers in any way grounded or sensible. And we find this all the time. And here, the confluence of the fields of neural networks and neuroimaging succumb to the same temptations and make the same mistakes all the time. From the Irish Times in 2011, we have our Irish Times science journalist, Dick Alstrom, who really ought to know better, reporting breathlessly from a study from a scientific conference which shows that white-collar criminals have different brains than non-white-collar criminals. White-collar criminals are people who have fallen foul of particular laws to do with practices involving documents, bureaucracy, finance, and so on. They don't have different brains. That's a tragic mixing of metaphor, and yet our leading science journalists in Ireland opened with White-collar criminals are equipped with tremendous advantages to help them carry out their work. Their brain structures are different, and this translates into mental attributes that suits their nefarious business. This essentializes this class of white-collar criminals and leads you to believe that the analysis of data could help you to identify them. 2011. The Guardian in 2020 reproduces this. Long-term offenders have different brain structure, study said. This kind of essentialism, this kind of conjuring up of types which are then claimed as natural kinds on the basis of the analysis of data, as if data could do this on its own, is toxic in our present society. And I hope one thing you get from this module is the skill to recognize such utter toxic nonsense when it arises.